Hey everybody, this is Larry. This is day 8 of the September Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord, and we're going to solve this problem live where I go over it as much as I can. Alright, today's problem is sum of root 2 leaf binary numbers. Okay, so given a tree, every node is 0, 1. Starting with the most significant to the bottom in the leaf for all the leaves in the tree, consider the number represented by the path. Okay. So in this case, it goes 1, 0, 0, and then plus 1. Okay. Yeah. So I think this one is a straightforward application of depth first search. You could do it in any way, but that's how the way I would want to do it. But basically, the idea is you want to only sum the answers at the leaves. So we'll have a function that checks whether it's a leaf, and then also just have someone that pass on what has transpired before, right? And once you do that, you just sum it all up. I think this should be straightforward, and it's going to be linear time because we look at each node at most once. So let's jump right to it, and then current. And I think the trickiest part is just taking care of the bookkeeping, as I would like to call it, meaning that you just have to keep track of things and make sure that what you're saying is true. If node is none, then we just return 0. And then now we check if a node is a leaf. If node dot so actually let's do current is equal to current times 2 plus node dot value, right? So what this means is that it's basically doing a binary left shift, because every time you go down one level, you're going to move that digit to the left by 1, and that's a left shift. And what that does in a binary number is multiply it by 2. So that's what we do here. And then now we check if left is none and node.right is none. Then we want to do some total plus or equal to current. Also have to make sure that we take the total from the global. And you could do some ways of returning it as well, but I like to do it this way. Sometimes just depends how you feel about it. For me, it just makes it clear how to separate them, because in this case, summing is distributive and stuff like that, and you don't have to do it in any order, so it doesn't really matter. But yeah. But definitely, practice your own thing. Otherwise, we want to do DFS node dot left, DFS node dot right, and also I guess we have to return here because so that we don't, if this is a leaf, this is the base case, and we want to return it. And then if not, we just go left and the right, and also we pass in the new current after we shift it by the value. And that should be good enough. So we just have to kick it off with the root and the default value of 0, and then we just return total. Are there more test cases? No? Okay. Yeah, so that looks good. Let's give it a quick submit. There may be some edge cases, but it should be okay. Cool. Yeah, so that was a pretty quick submission for an AC. Accepted result. So this is again linear because we look at each node once. The space complexity is always going to be adverse to height of the tree because you have that stack, that implicit stack that's created by recursion, right? So it's going to be O of H, which is in the worst case O of N as well. But yeah, so I think the key thing to know is just figure out something that figure out what changes as you pass from one node to the next node, going from top to bottom in this case. And once you figure that out, that invariant, then you're able to keep, and if that invariant, and it should be because that's why it's called invariant, is true throughout, then you can keep doing it. And then, so that's the relationship. And here it's just about shifting it to the left and then adding the current value and then keep on going recursively. Yeah, that's all I have for this problem. Let me know what you think. Again, I take feedback very well generally, so let me know if you have questions. I'll answer them as much as I can, and you know, it will inform how I go with these prompts in the future. Anyway, I will see y'all tomorrow. Bye bye.